Hello geometry students, and welcome back to another video lesson where we continue to look at different types of quadrilaterals and their special, unique properties. Today we get into trapezoids, where we're going to look more so at some of those properties for specific trapezoids. So in order to really understand what we're doing here, we got to remember that for a trapezoid, if a quadrilateral is going to be classified as a trapezoid, it needs to have at least one set of parallel sides. So that's what this shape down here shows. Top and bottom are parallel. What that does is it creates a very unique relationship with the interior angles here. Because they have one set of parallel sides, some of the theorems that we learned back in chapter 5 and 3 relating to parallel lines and angles are going to be very useful here. So I'm just going to try and maybe take off this right side for a moment, right? This line is parallel to this line, and it's cut by this transversal right here. Right? We know that those two are parallel. So what we're looking at is angle 1 and angle 2, as I'll label them, in this diagram. Anybody remember the name of 1 and 2? Hopefully you said same side interior. So same side interior angles. And the rule here with same side interior angles was that they had to equal 180 degrees. So if you look in this diagram, we know that angle 1 plus angle 2 has to be 180 degrees. And that's from the earlier chapter on parallel lines and same side interior. Well, the same exact property then applies to these two over here, right? Here's a parallel line, same parallel line, but now this is just being cut by a diagonal, more of a slanted transversal. So 3 and 4 in this picture happen to be 3 and 4, meaning they also, angle 3 plus angle 4 has to equal 180 degrees. So every trapezoid, as we know, every trapezoid is 360, the whole entire thing. But the two angles that are in between the parallel lines have to total 180. So we get this trapezoid angle theorem. In a trapezoid, any trapezoid, consecutive angles, so the angles that are next to each other between the pair of parallel lines are supplementary. Again, that means that they are 180. So if this here I said was 90, this would have to be 90. If we said this is 130, this would have to be 50. All right, in between the parallel lines on the same side interior, and that comes way back from chapter 3. Now this gets even more specific when we go to the isosceles trapezoid. All right, so here's the diagram of the isosceles trapezoid. Remember that the top and the bottom in this case here are parallel, and in order for it to be isosceles, the two base angles have to be congruent. Well, if that's true, right, if this base angle and this base angle are congruent, because that says it's an isosceles trapezoid. So let's just say this is 70, and that makes this one 70. The theorem and property we just learned said that these two have to total 180, which makes this one 110. Well, if I look here, these two have to total 180. They got to be supplementary, so this is 110. So notice in an isosceles trapezoid, both sets of base angles are going to be congruent. The other part that this then does is it makes the non-base sides congruent. The non-base. And the base sides come from our parallel lines. So the non-base sides, in this picture, the one on the left and the one on the right, would have to be congruent. almost imagine it looking like an isosceles triangle, where if 70 is here, the opposite side, if 70 is here, the opposite sides have to be congruent. The other unique part about an isosceles trapezoid is they have some symmetry. All right. Regular trapezoids typically don't have any symmetry, but an isosceles one does. And it's the perpendicular bisector of one base to the perpendicular bisector of the other. Bisector means it cuts it in half. So if I were to tell you that this is the midpoint, that means if I draw the perpendicular bisector right there, perpendicular, and it bisects the top. Bisecting means it's half. That line, if I actually continue to extend it, is also going to be the perpendicular bisector of the bottom base. Okay, and that becomes our line of symmetry. But it has to be a perpendicular bisector, meaning it intersects at 90 and it bisects the base into two equal halves. Now we use a lot of this to then find missing parts in different types of trapezoids. So here's an example. What should angle T be in this picture? Well, the property says that if this is a trapezoid, and I probably should have put the parallel sides on there, but this is a trapezoid, that these two have to total 180. So angle T plus 85 have to equal 180, and if we solve that, T would have to equal 95 degrees. So it's a basic level of understanding that together they're supplementary. Example 2 expands it a little bit. WXYZ at the right is an isosceles triangle. It is an isosceles trapezoid. Top and bottom here, bases are parallel, base angles are congruent. Bases are WZ and XY, so it means these two are parallel. Find as many lengths and as many angle measures as possible. As many lengths and as many angle measures as possible. So we're going to look over here and let's just start with all of the angles. All of the angles. If angle W is 45, that means the other base angle, angle Z, has to be what? It also has to be 45. Do we know any other angle measures? Well, we should know that W and X have to be supplementary, so they have to add up to 180, which means X is 135. But because this is an isosceles trapezoid, we also know that Y is going to be the same, or 135. Right? If we made this one down here 45, that meant this one would also have to be 135. Now, if I look at the sides, do I have any information on the sides? Well, I don't have any of the bases. Right? They don't tell me the bottom left side here, the bottom right side, but they do tell me between the bases over on this side is 42. Remember, in an isosceles trapezoid, we learned that the two sides between the bases are also congruent, meaning segment WX would also need to be 42. Okay, 42. Last example. All right, find the measure of angle C in this trapezoid. Again, I'm going to put our arrows on there to show that they should indeed be parallel. Find the measure of angle C. All right, well, what do we got? If this is 90, and it's a trapezoid, that means this one would be 90. I don't necessarily need that, though. What do I know about these two angles on this side of the trapezoid? They do indeed have to total 180. So if I add those two angles up, 110 plus 3x minus 2, that has to equal 180 degrees. So this is 108 plus 3x equals 180, I subtract the 108 from both sides, we get 3x equals 72. And if we divide by 3, we get x equals 24. All right, should we stop there? Not quite, right? It doesn't want us to find x. It wants us to find the measure of c. So I'm going to take and plug that into the measure for c now that I know x is 24. 3 24s. So 3 times 24. 24. 48. 72 minus 2 equals 70. Now, wait a second, Mr. G. Why did we do all of that work when we knew angle B was 110 and all we had to do was take it away from 180? And you're exactly right. You could have just said that angle C was 70 from the get-go. If they were asking you to find x, you would have needed to go through this process to help you find the value of x. That gave you that degree measure. So be very careful with how they ask the questions and what question or answer they're actually looking for. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.